Eightfold Way, 1961 to 1964. The Mendeleev of elementary particle physics was Murray Gell-Mann, who introduced the so-called Eightfold Way in 1961. Essentially, the same scheme was proposed independently by Niemann. The Eightfold Way arranged the baryons and mesons into weird geometrical patterns according to their charge and strangeness. The 8 lightest baryons fit into a hexagonal array with 2 particles at the center. The baryon octet S equals 0 for neutron and proton, S equals -1 for sigma minus, sigma 0, lambda and sigma plus, S equals -2 for xi minus and xi 0. This group is known as the baryon octet. Notice that particles of like charge lie along the downward sloping diagonal lines q equals +1 in units of the proton charge for the proton and the sigma positive, q equals 0 for the neutron, the lambda, the sigma 0 and the xi 0, q equals -1 for the sigma negative and the xi negative. Horizontal lines associate particles of like strangeness. S equals 0 for the proton and neutron, S equals -1 for the middle line and S equals -2 for the 2 xi's. The 8 lightest mesons fill a similar hexagonal pattern, forming the pseudoscalar meson octet. The meson octet S equals 1 for K0 and K positive, S equals 0 for pi minus, pi 0, eta and pi positive, S equals -1 for K minus and K0 bar. Once again, diagonal lines determine charge and horizontals determine strangeness, but this time the top line has S equals 1, the middle line S equals 0 and the bottom line S equals -1. This discrepancy is a historical accident. Gell-Mann could just as well have assigned S equals 1 to the proton and neutron, S equals 0 to the sigmas and lambda and S equals -1 to the xi's. In 1953, he had no reason to prefer that choice, and it seemed most natural to give the family of particles proton, neutron and pion a strangeness of 0. After 1961, a new term hypercharge was introduced, which was equal to S for the mesons and to S+1 for the baryons. But later developments showed that strangeness was the better quantity after all, and the word hypercharge has now been taken over for a quite different purpose. Hexagons were not the only figures allowed by the Eightfold Way. There was also, for example, a triangular array incorporating 10 heavier baryons, the baryon decuplet. The baryon decuplet S equals 0 for delta negative, delta 0, delta plus and delta plus plus. S equals -1 for sigma star minus, sigma star 0, sigma star plus. S equals -2 for xi star minus, xi star plus. S equals -3 for omega minus. Now, as Gell-Mann was fitting these particles into the decuplet An absolutely loving thing happened. 9 of the particles were known experimentally, but at that time the 10th particle, the one at the very bottom with a charge of -1 and strangeness -3, was missing. No particle with these properties had ever been detected in the laboratory. Gell-Mann boldly predicted that such a particle would be found and told the experimentalists exactly how to produce it. Moreover, he calculated its mass, as you can for yourself in problem 1.6, and its lifetime, problem 1.8, and sure enough, in 1964 the famous omega- particle was discovered, precisely as Gell-Mann had predicted. See figure 1.10. Figure 1.10. The discovery of the omega-. The actual bubble chamber photograph is shown on the left, a line diagram of the relevant tracks on the right. Photo courtesy Brookhaven National Laboratory. Since the discovery of the omega-, no one has seriously doubted that the Eightfold Way is correct. A similar thing happened in the case of the periodic table. There were 3 famous holes, missing elements, on Mendeleev's chart, and he predicted that new elements would be discovered to fill in the gaps. Like Gell-Mann, he confidently described their properties, and within 20 years all 3, gallium, scandium and germanium, were found. Over the next 10 years, every new hadron found a place in one of the Eightfold Way supermultiplets. Some of these are shown in figure 1.11. Figure 1.11. Established Meson nonets. Obviously, we are running out of letters. It is customary to distinguish different particles represented by the same letter by indicating the mass parenthetically in mega electron volt per c square. Thus, K star 892, K star 1430, K star 1650, and so on. In this figure, the supermultiplets are labeled in spectroscopic notation. See chapter 5. At present, there are no complete baryon supermultiplets beyond the octet and decuplet, although there are many partially filled diagrams. This is not to say there were no false alarms. Particles have a way of appearing and then disappearing. Of the 26 mesons listed on a standard table in 1963, 19 were later found to be spurious. In addition to the baryon octet, decuplet and so on, there exists of course an anti-baryon octet, decuplet, etc. with opposite charge and opposite strangeness. However, in the case of the mesons, the antiparticles lie in the same supermultiplet as the corresponding particles in the diametrically opposite positions. Thus, the antiparticle of the pi plus is the pi minus, the anti-k minus is the k plus, and so on. The pi 0 and the eta are their own antiparticles. Classification is the first stage in the development of any science. The Eightfold Way did more than merely classify the hadrons, but its real importance lies in the organizational structure it provided. I think it's fair to say that the Eightfold Way initiated the modern era in particle physics.